with evaluating logarithms using your calculator. So you have so far been, not assessed, but checked to see if you can evaluate logarithms mentally. Like log base 2 of 4 is 2, because 2 squared is 4. Log base 2 of 8 would be what? 3. Log base 3 of 9 would be 2, right? Log base 4 of 2 would be what number? 1/2, right? Okay, you guys did that when you did that bonus point worksheet. So now what's going to happen is we're going to get to numbers that aren't so friendly. So here we have log. I assume that the base is what? 10. If it's not there, we assume it's 10 because that is our common log of 327.1. So whenever we are able to take something to the common log, we can use our technology and just evaluate it. So push into your calculator log of 327.1, and what do we get? Yep, 2.14680. So if we round to, let's say, 2 decimal places.
It's 2.514.
Yeah, so 2 decimal places would be 2.51 or 52. Okay. So, can you evaluate something with the log button on your calculator? Yes. Okay. Good. So we don't need to go through all of these then. So what's going to happen is now we're going to look at word problems that involve logarithms. You are going to be given these formulas. So pretty much just here's the formula, plug in whatever it is that you need to find. So our first formula is to find the pH of a solution. So to find the pH of a solution, the formula is you take negative of your log of whatever your H3O plus is. Okay. So we want to find the pH of water with hydronium ion concentration of 1.2 times 10 to the negative third power. So if this is my formula, I'm going to input the 1.2 times 10 to the negative 3 power in place of my hydronium ion concentration, and I just have to then evaluate. So my pH is equal to the negative log of 1.2 times 10 to the negative 3 power. What does 1.2 times 10 to the negative 3 power look like as a decimal?
1.012.
Yeah, so we need to move our decimal 3 places to the left. So that's 1, 2, 3. So that means I'm going to put 2 zeros in front. So now let's use our calculator. So hit the negative button, hit the log button, and then 0.0012. And I get a pH level of what? 2.92. You guys trust me on that?
Wait. I don't care why are you moving the decimal place?
Because it's written in scientific notation. So that I can put in a decimal into my calculator instead of scientific notation.
I thought we just multiplied that and then we moved it after we got to 0.0012.
Oh, no, because you're taking the log of this number. You're finding the log of 1.2 times 10 to the negative 3 power. Okay? All right. That's our first problem. Got it?
Same thing.
All right. So what would be your hydronium ion concentration of the drinking water if your pH was 6.5? So where's that 6.5 going to go if that's my pH? That's going to go on the left side of my equation, right? So now if my pH is equal to 6.5, we need to find our hydronium ion concentrations, or H3O plus. So 6.5 is equal to negative log, and I'm just going to make that an x for now. Okay, so now we have a logarithmic equation that we now need to solve for. The first thing I would do is get rid of this negative in front of my log by either dividing it or multiplying out, which would make it become a negative 6.5 equals log x. So to solve a logarithmic equation, you have to do the inverse of a log, which is exponential. So how do we convert this to an exponential equation? My base of my log is 10. 10 to what power? Negative 6.5 is equal to x. So now calculator crunching, 10 to the negative 6.5 power gets me 3.16. Now your calculator is going to have a bunch of decimals, and then you're going to see a little uppercase e and a negative 7. Do you guys see that? Yes? Yes? Okay. So that just means scientific notation. So that means it's going to be times 10 to the negative 7 power. So that would be our hydronium ion concentration if our pH of the drinking water was 6.5. I don't even know. You guys probably know better than I am. What's a good pH level for your water? 6 or 7? Kyle? Question?
So how did you, is the 3.16 a basic? Like,
What do you mean?
How did you get the 3.16?
When I typed in 10 to the negative 6.5 into my calculator?
Okay.
Like on your calculator, type in 10 to the negative 6.5 power. Did you do that on your calculator?
No, I'm just trying to figure out if you did that, then how did you get the negative 7?
Because that's what my calculator told me it was. So on my calculator, if I do 10 to the negative 6.5, it's going to give me this result.
Oh,
And this E tells me it's scientific notation.
yeah, okay.
Okay? That's where that came from. All right. Now let's move to sound. So again, I would just jot this formula down instead of all these words. So this formula tells us the loudness of sound is measured in a unit called your decibel. To measure the sound, we first assign an intensity of I sub 0 to a very faint sound called the threshold sound. If a particular sound has intensity I, then the decibel level of this louder sound is given as the following. So your decibel is equal to 10 times the log of the intensity divided by the threshold sound. Okay, so again, what's going to happen is it's just going to give us this formula, and then we got to use it by plugging things in. So we have the formula written down. So D equals 10 log I is your intensity. And you do not need to memorize these formulas. And I sub 0 is your threshold sound. Just need to be able to use them by plugging things in. All right, so our first example is going to use this formula. Well, first example for this formula. If music is delivered through the earphones on the iPod and has intensity I, so my I is equal to, intensity I of Oh, now I'm confused. Why does it say I of 3.162 times 10 to negative 10 11th? I sub 0. Oh, I think that's just the number that goes in place there. So my I divided by I sub 0 is equal to 3.162 times 10 to the 11th. That's what's happening. So to find our decibel, we're taking 10 times the log of that number. So 3.162 times 10 to the 11th. So now I gotta do some button crunching. Now there is a way to do scientific notation on our calculators, if I remember correctly. How do I do it? There it is, EE. I see the double EE. So if I want to just type in, it's on my calculator. Can I get rid of the screen for a second? So if I type in 10, there we go, times the log of, what was it, 3.126? Did I get that right? I did, 162, not 26. Okay, and then you can hit second, and then the comma sign, and it brings up that scientific notation E. And then I can just type in 11, and it'll give it to me in scientific notation. So I would round that to 115 decibels. Would everybody be able to do that on their calculator? I mean, you could move your decimal place over 11 times to the right. That would just be a lot of zeros that you're going to be putting into your calculator. So we have 115 decibels for our answer there. So 115 decibels. I don't know. How do we just write decibels? Not very. It's just dB. dB. There you go. All right. So, can we use our calculator to evaluate logs? Yes? Okay, so the next thing we have to cover is natural log and then change of base. So, the LN button on your calculator is what represents your natural log. And the reason why it's called a natural log, unlike the common log that has a base of 10, your natural log has a base of E. Okay? And E is a very special value. If you typed in E to the 1 power on your calculator, so you can find E on your calculator, it is at the LN button. Get rid of this for a second. If you look at the LN button right above it in the second part, the shifting part, you see E to an X. So if I typed in second and then natural log of E to the first power, E is equivalent to 2.718. I don't know if you guys remember from last year in Algebra 2, but when you were doing compound interest, when I was doing it with when I taught Algebra 2, you keep compounding it. Do you guys remember doing compound interest? Yeah. So if you have money in a bank account, it earns interest. You can earn interest annually, you can earn interest quarterly, monthly, daily, and then compound interest continuously is that Herc equation. Remember that? A to the P, A is equal to P, E, R to the T. Does that look familiar to you guys? Yep. Okay. So, as you keep compounding interest, what's interesting, if you start with $1, it keeps getting closer and closer and closer to the natural number of E, which is 2.71828. It's just a special number, just like pi is a special number, E is a special number. Okay, so when we're talking natural logs, all we really care about is that it has a base of E. Okay, and so the natural number E is a fundamental number that approximates to 2.718281828. It's just kind of like pi. It's just that we're very used to pi because that's used often. in the geometric world. Okay, E is used very often in the finance world. So if you were to become some type of finance person, you would be very familiar with E. Which then means that you have to be very familiar with natural logs, because a natural log has a base of E. And how do we convert between logs and exponents? We use the base of one to get the base of the other. Okay, so natural logs has a base of E. What is E? E is a fundamental number that approximates to 2.718288128. Do you need to have that memorized? No, because your calculator could easily tell you what that number is. And we're just going to be using our calculator to evaluate things anyways. So, on your calculator, can you evaluate the natural log of 0.5841? So if you hit natural log button, which is the ln of 0.5841, hit enter, we get negative 0.538. We go to 3 decimal places. Okay. Which if we converted that, I know it's not asking us to do it, if I converted that into an exponential equation, it would be the base of my natural log, which is E, to the negative 0.538 is equal to 0.5841. Now it's not going to be exact because we rounded our answer, but it'll be pretty darn close. Okay? Alright, so can you use your calculator to hit the natural log of something? Yeah? So now let's look at an equation that has the natural log in it. So here we have the altitude in meters that corresponds to an atmospheric pressure of x millibars is given by the logarithmic function defined by such. So f of x is equal to 51,600 minus 7,457 natural log of x. Okay, so x is representing my atmospheric pressure. F of x is representing my altitude. So altitude, x is representing atmospheric, if I could spell, atmospheric pressure. All right, so we're going to use that function to find altitude when our atmospheric pressure is 400 millibars. So what are we going to do? We're just going to throw 400 in place of x. So f of 400 is equal to 51,600 minus 7,457 natural log of 400. So on the graphing calculator, I would just throw that all in one shot because it will do order of operations for me. So 51,600 minus 7,457 times the natural log of 400 gets me a final answer of, so my altitude at 400 is 6,921.6, do we know units? Meters. Okay. So plugging it into a formula, can you evaluate using your calculator? I think we got that. What if I had to do that same equation but backwards? So what if instead, can I get rid of this? Instead it said use this function to find atmospheric pressure. Atmospheric pressure when your altitude, let's see, when your altitude is 12,090.5 meters. Then what would you do? How would you solve that? Well, one, where would this go? In place of f or f of x or x? That would go in place of f of x, altitude. Your altitude is 12,000. So if I plug it in for f of x, so 12,090.5 is equal to 51,600 minus 7,457 natural log of x. So now how do I solve that equation? Yep. Okay, good idea. Let me erase this stuff so I have space. So there's my equation. So if I subtract 51,600 from both sides, I get negative 39,509.6 is equal to negative 7,457 natural log of x. Then what would you do next? Divide. So divide out negative 7,457. So negative 7,457. Oops. 5.298 is equal to the natural log of x. So to solve any logarithmic equation, you have to do the inverse of it, which is exponential. So turn this into an exponential equation. What's my base of the natural log? Natural log. Base of natural log is e to what power? 5.298 is equal to x. So now that's just a calculator. So second natural log gets me my e to the 5.298, which is 199.9 approximately. I don't know what's milli. What was the units for atmospheric pressure? Milli something. I forget what it said. Okay. All right. So using formulas. Think we got that? All right. So the last thing we have to do is change a base, which is quite easy. So what happens if you do not have a log that is a common or natural log, so that we can't use our calculator to evaluate it? Well, you have to use the change of base rule. So if you have a log of some base a that is not 10 or is not e to some x, you can convert it to a new base, and we're always going to probably convert it to a base of 10 just because that's easiest. So I can convert it to a new base of my choosing, and I'm going to choose wisely to convert it to base 10, because my calculator does base 10s, where your x gets attached to the log in your numerator, and your a gets attached to the base of the log in your denominator. So the way I like to remember it, your base goes into the basement. So your base gets attached to the basement of your fraction, to the bottom. So log base b of x divided by log base b of a. And the only time we use this is if I am given a logarithm that I need to evaluate that I can't do mentally. Like I can't do log base 2 of 5 mentally. I don't know what 2 to what power is the fifth, is 5. That's a little bit hard. So what I would need to do is I would need to use the change of base rule so that I can use my calculator. So you can either take it to a common log, or you can either take it to a natural log. Either will get you to the same answer. That's up to you on what you want to pick. So So if I needed to evaluate log base 5 of 12, well, I can't do that easily mentally because I don't know what 5 to what power is 12. That's not simple. So if I wanted to use common logs, which means it would have a base of 10, I would take the log of 12 and divide it by the log of 5 on my calculator. So on my calculator, I would do log 12 divided by log 5. So the base of my original log goes to the basement. Try it out on your calculator. Make sure you get it right. I'm getting 1.54. Or, if you don't like common logs and you like natural logs better, you would just do the same thing but with the ln button. So the ln of 12 divided by the ln of 5. So ln of 12 divided by ln of 5, which gets me the same number of 1.54. So that's up to you on which base changing you want to go to, whether it's common or the natural. I have it go to common all the time, but it would not be incorrect if you went to natural logs when you did your change of bases. Okay, so what would be, no, we don't want to do that. Let's just do one quickly. What if it was log base 3 of 15? Well, don't say base. It would just be log 15 over log of 3, because your base would be 10, right? So log of 15 divided by log of 3 gets me 2.46 about. Do not make the error. This is not the same as log 5. Don't take the 15 and divide it by 3 and then say, oh, it's the log of 5, and then type in the log of 5 into your calculator and get 0.69897. That's not the same thing. Okay? Because it's the log of 15 divided by the log of 3. All right, so that is that. 11.